All right, hello. We are live. Hope everyone's having a good weekend. I have an echo. Audio sounds good. People were saying the other last couple of streams it was a bit quiet, but it sounds better to me. If you're here, you can hear it. Let me know. Because it sounded good to me also on the stream, but I might just have my volume up high. Yeah, okay. I think it sounds good. So let's get started. What are we doing today? This is a question I do not yet know the answer to. One thing I do know that I want to do is I want to start ironing out some of those bugs. So if you were here the other day, here, let me share my screen. How can I come over here? Just go to Google, open this. Make sure I have my stream up on the other monitor muted so I can check the audio if anyone says it's not sounding too good. And I almost hit stop streaming, but here we go. Now, the other day, there were a couple of problems and bugs with the sort of open, high, low, close values. Hold on, let me put something under my chair so it doesn't flop. My chair is awful. Nice. All right, so there were some bugs with the open, high, low, close that we would like to iron out today. And I suppose we'll start by seeing what those bugs were. So one problem, maybe we can visualize these. Let's go back to our notebook here. We'll do the light theme for today. We were using this testing bot thing, this testing bot script, I should say. And we'll start it up. We'll just run all the cells and I'll kind of walk you through what we were doing. Now, in our real data, this is how our real data was looking. Oh, what's the problem? Key error side. Okay, let's see what's up. No, where's our real data? So we had our real trade data. We had oh, here it is. Whoops. So something is up with the candlesticks. You know, what I think it is that how do you say it? I think that the exchange, it passes us back information very frequently about the candlesticks, which it shouldn't be. So I think it's this very last value that we should be taking. So let's take a look into the actual file that hosts this data. We'll do this, I guess, just from the command line. So if we were working in the example script and we had this bot data folder from yesterday. Let's look at the bot data OHLC, OHLC.csv. And actually, let's just load it in because it's a bit ugly to look at. So we have it loaded in, obviously. Let's do a new example file that I will remove eventually. I'm also going to clean up the file system today and we'll extract any sort of hidden gems from the streams that we've been doing to migrate to a more permanent form of the code. And let's just call it troubleshoot ohlc.ipynb. And we will go ahead and copy all of this information here, paste it right into here, and let's see what we get. Okay, so we do have this. You're plotting so much data. Yeah, okay. That's okay. Thank you for the warning. And I've had this running, so we have much more data now than we did yesterday. If you were here yesterday, it was like 25 bars we had because we were pulling it live, the 1 minute bars live. And the stream is only so long. So what do we have this data frame called? Just df. Let's do a little df.head. Yep. Now, let's look from, let's grab because the initial data is good because it's from the snapshot. I think they give us like 25 bars. So just to be safe, let's slice. I'll call it df slice equals df.iloc. And we'll go from, 100 on. We have plenty of bars. So let's do dfs.head. And it seems to me, yeah, that we have a lot of these entries. Let's get some more data here. a lot of these, you see a lot of these entries are at the same minute. So it's 14, 14, 14, 14. Now, how do we want to handle this? And the volume keeps going up. So what I think is happening is the live feed must sample, every however many seconds. We can actually just take a peek at this. I was looking at Doge again. What is it? Kraken V2 API. We'll just go to their WebSockets API. I always click the wrong link here. Kraken API. It's very slow today. Don't know why my internet seems to be slow. Luckily, we don't need the internet for what we're doing. I mean, I guess for streaming, but that's more of an upload side thing. I think my download speed has just been awful. So what do we have? Let's really read the documentation here. OHLC channel streams open, high, low, close. For the specific interval period, the feed accepts a list of symbols. Yep. Acknowledgement for the response in each symbol. And what are we getting? Snapshot and update responses. Update responses share the same schema, of course. Hold on, I'm going to mute. I have to cough a bit. Alrighty. And what was I going to say? Okay, so but we need some more info about how often this thing pings us with the info. So let's open one of these streams here, one of these data streams. We'll just do vim quick run ohlc.py. And I believe we have one of these in the examples folder already, don't we? These were some nice data sets that was sent by someone in the Discord. So thank you to Panday for that. I don't know if I said your name wrong, but I appreciate these candlesticks you sent. It's a bunch of data that we could probably use later today if we get to some machine learning. I think it's like 90,000 bars or something, you said, which is much larger than my 5-minute bars for Bitcoin over the last couple months. Okay, so, all right, what am I doing? We need, we don't have an OHLC example. Maybe it's in the web app. Yeah, we do. Okay, so let's just copy from the web app. OHLC examples here, vim OHLC examples. We load in this stuff. We don't actually need to authenticate, we learned yesterday, for any feed other than the tick data. So there's no need for this right now. Interval 1 minute, Bitcoin USD, trace false, data dir. Yeah, okay. Now one thing I want to do is let's go to the definition here. If you're using NeoVim, you can just do GD for that. I think if you have Vim too, maybe you can configure that. And of course, I believe it works in Visual Studio Code, and Cursor as well. But regardless, here, let me get my arm list out. Let's take a look. Let's print the message because I'm confused a bit about how often we're getting these messages. So let's go ahead and just print message every time we get one, and let's run a feed. Did I modify this? Oh, I did, right. Let's also do a little tmux session. So this is where we run the data feed, and then we'll have our sort of monitor data feed file here, or window pane. Monitor feed. So let's go ahead and run the feed here. If you don't know tmux, it's a nice, tmux stands for terminal multiplexer. And so we're printing out this data, right? Let's just keep an eye on it for a second. So we get a snapshot of a bunch of recent candlesticks. And now for some reason, we're getting updates much more frequently than 1 minute, which is a bit annoying. So how can we handle this? I think what we need to do, where's our timestamp? Timestamp here, 10:33, 34. Oh, wait, where's our... Hold on, I'm a bit confused by this. 1910, 1910:50. Oh, so 10 is the minute. Whoops. So we have 11, 1911, 1911, 1911. Why do we get so many of these? I don't know if it's some fixed amount of volume that comes from the exchange, gives you an update, or they have a very poorly documented API, which is very, very annoying if you're trying to figure out what's wrong here. And example update, does it say anything about, no. So let's take a look at these t-end things. So timestamp is a fixed minute thing. So we get a timestamp here, and this is presumably of the actual incoming time. Interval begin and interval, why are there two different timestamps that don't line up? Um, So for 5-minute candles, the interval begin is 25. So obviously the ending time of the interval should be 30. And here we're getting, stuff at 26. But it doesn't give us any information about how often this is coming in. So I guess what we should do is we should probably build the index out of this timestamp as opposed to the time that we're getting from the exchange. So I'm going to actually, no, I will cancel that for now. Let's go ahead and try and fix this. So where were we? Let's look at feeds, and we'll go back to where we were in here. So when we build the index, we might want to build it out of this second timestamp. So what are we saving? We are saving t-end as, where's t-end? Timestamp. Data timestamp. So we shouldn't be getting any more of these, because if you look at this, data timestamp should be a very fixed thing. And let's see what we're building our index out of when we create the data frame. Let's keep an eye on that. Let me keep the chat open over here just so I have an eye on that in case I miss any messages. And let's see. So these have the same index. So we are building it out of the correct thing. Wait, what's our df.index here? dfs.index. So we have many overlapping indices, which is, I actually didn't even know you can do that. Can you do that? Is it bad practice to have multiple indices the same in a data frame? The answer is obviously yes, but I didn't even know it's possible. So how might we do this? Let's think about, okay, so let's look at the df head again. So our problem is that, and let's only look at these timestamps for now, because that's really what we care about. So let's do dfs, and we'll do t-end. How about, can you do index? I'm not sure. dfs.index, I'll try this. Let's see if this works. No, you can't do index in there, but we know that t-end is our index. Why is this not working? Oh, I have a typo. That's why. Oh, that might have been the problem before too. So let's see, dfs.index. Why does it keep deleting my bracket? Okay, no, that's not there. Let's remove this. Timestamp, was it? T-start. I already forgot all the column names. dfs.head. So we have t-end, t-start, and what's this other one? t-true. So give me this, and we'll go ahead and do t-true, uncomment this, and what's the problem? t-end is not in, is it not? It's right there. I see it. I guess it's because it's our index. What if I do this? Okay, here we go. So because it's our index, it's going to be put out regardless. And let's just look at the first 10 or something so we don't get this annoying ... Let's go for the first amount where we hit a new number. Okay. So we're getting a lot of these. Is it 60? Is it 1 per second possibly? No, it is not. Because these ones start coming in pretty much one by one. Late today? I guess, yeah, it depends where you are, right? It's pretty early today for me. um, well, it's not that early. What time is it? 1 or something? 12? Yeah, are you in India? What time is it? Yeah, it's 1 for me, 1:15. Today we are looking at ironing out this bug with the OHLCs. So when we pull the feed for the candlesticks, oh, you're in DC. Nice. Yeah. So when we pull the feed for the candlesticks, what is happening is we get the snapshot of the old candlesticks fine, but once we start updating, it seems to give us multiple updates per minute. So we have to probably simply pull the last time frame associated with each of these indices. So let's try this and let's see how that looks. Let's try pull only the most recent entry corresponding to the end timestamp. Let's see. Well, first let's check that these do come in descending order. So the time is increasing here. This is sort of the real time that it's sending it out at. And so the last one's 51. So this does go down. So we can simply pull the last entry of each one of these. So pull only the, what would it be called? I guess the last entry in, last row in the data frame corresponding to each unique end value. So does this work? We get 14, 16, 17, 18. So I guess it skips 15 for us. And then we can do, yeah, you could sort, but it's already sorted. So we're just really trying to pull the last entry of each one of these. So I don't think we even need this reset index though, right? There should be no need for that. What is reset index doing? I don't think that's going to do anything for us. Let me do one of these. Quick check here. Open Microsoft Paint. Let's get rid of this. Run it here. Pull this. So did this do anything? No. Yeah. So we don't need that. Well, I should check the values, I suppose. Reset index. All these, let me just do this. So we already have all the candle data in here. The thing is that the WebSocket sends more than one candle per minute. Yeah, so like we have all the information here, but the problem is if we don't do this group by thing, we get multiple, like at 14, 14, 14, 14. So we should only be getting one of these. And I think it's just that the WebSocket's set to send you data in some interval that it does not describe anywhere in their API. It has to be in, I mean, it should be in there somewhere, but a lot of times these APIs are just poorly documented. So it says nothing about this, unfortunately. And so, okay, so that was for this one. And so like really it should be just this last one as the time slice for this. So this is between, 27 and 36. There should only be 9 candles, but you can see there's like hundreds. Okay, so this was with, what was this one with? No group by? I forgot already. This is with reset index, yeah? Yeah, so let's try without reset index because I don't know what that's doing. See if any of our numbers swapped around. Nope, looks good. Just kind of eyeing up all the different columns. 4490, 149874. Yeah, looks good. So we don't need this group by. Can you make a key with hash map? We could, but basically you would just throw this, that's what this is effectively. So you could think of this as just a hash map where each of these are, um, it would be like a nested hash map. So it would be like, say, hash equals timestamp, which would be like exactly what you're saying, 1, 2, 3, 4, something like this. And then the keys would be, open, 100, I, and so on. So that's basically what we have here. The problem for us is that we're getting multiple entries of this per timestamp. So these should be unique, right? One per 1 minute or 5 minute candlestick. But the way that they return the values to you, you get multiple per timestamp. So we need to pull. So what we're doing now is we're pulling only the most recent one. And let's see how it looks. So let's do visualize bars, DFS, and let's see if it looks more reasonable. Nice. So this did fix it. And let's check against this is Doge USD pair. So let's, can you join what? Yeah, join what? Let me see this thing. So what time are we looking at? We're looking at yesterday somewhere around 6 p.m., I believe, on Discord to discuss. Yeah, off stream for sure at some point. I'm not going to live stream I don't even have it set up I'm not even logged into Discord on the streaming computer. Maybe I can set that. Might be a good thing to do in the future is we can do like a live kind of, people come in. That might be a good idea. But I'll have to do that and set that up for some other stream in the future. It's actually a good idea. I never even thought of doing that. So, where are we? October 9th? Nah, 21, 24. We should be pretty clear where this is. Yeah, for sure. Oh no, we're on 5 minute. No, we're on 1 minute. Okay, so it looks like this is where we are looking. Possibly? It's very difficult to tell. Let's see, 144. Oh no, this is definitely not it. Where are we? 20th, so we need 19th October. Oh, we're way deep into today. That's why. 19th October 21, 24, 21. I'm not sure if it's the correct. This might be New York time, or actually, I don't even know what time this is. So let's take a peek. Oh my gosh, I forgot their freaking thing resets whenever they sample a new bar, their thing just resets on you. I totally forgot about that. So it's around 144, so it has to be this time frame here. Yeah, so it's a 2 hour difference, it looks like. Oh no, it's the same time. What am I talking about? 23:15. Okay, so let's zoom in here and make sure that we have the correct thing, and let's really hope they don't resample on me and cancel this. So at 23:17, right around here, we have a big go up, and oh my gosh, this thing. I'm gonna have to screenshot it, I guess, and hope it does. There has to be some way to turn off this live resetting of your plot. They have a snapshot function. 23. What was it? I already forgot. 23:15 on the 19th. So let's zoom into here, and let's hope that it doesn't reset on me. Let's open this in Paint, paste this in. I forgot to grab the timestamp. Probably want that so we can compare. Okay, now we can compare between our candles and these ones. So let's look around 2114. We don't have that far back. Let's look around 23 would be right around here. 23. So we get this slight downward movement. That's this right here. A couple of these flat candles. And then we go way up. And then we go way up. Down to red, to green, to green, to red, to green, red, for green, red, for green. Yeah. Okay, so we have it right. So this is the correct way to do this. So that will be, so that's good to know. So that bug is now sorted. Probably, so the way to do this is whenever we load in our candlesticks, I'm going to write trying to think of the best way to deal with this. Probably, I'm not sure exactly what's going to be the best way to deal with this. I think we can simply do this whenever we load it. So let's give it a shot. When we load this in, let's go ahead and say df.group by the end. I'm reading Advances in Financial Machine Learning at the moment. When you read it, did you understand all the math in it? I mean, I do, but I have like a pretty extensive math background. So, and I still get like some of it is tricky. So, I mean, like I understand the math, yeah. So if you have any questions on the math, feel free to drop them and we can look into the book. Let me open up the book actually. Some of it is tricky though. Like it's very, especially the implementation because it's he does a good job, I think, about talking through the theory and kind of explaining the motivation for things. But when it comes to the implementation, it's not always clear what you have to assume some initial condition for or provide an initial guess for, especially like I was getting tripped up with those imbalance bars, implementing those the other day. And the math isn't really complicated in my opinion, but the implementation is a bit tricky. So if you have any questions on the math, I can open up the book here. Let me, I don't think I'm allowed to stream just like the whole book. So let me just put this on for a quick second. Advances in Financial Machine Learning. And I'll come over here, just opening the book. Can I open it with, oh, it's so annoying how I can't open this with Brave browser. Let me throw this into Brave browser. Open the book. I'll open a couple copies of the book so that we can hop around. And if you have some specific chapter or something, just let me know. We can go over it for sure. I'm just a student, so for me, it's a bit demotivating. Yeah, don't get demotivated by it. I mean, it really depends on what your background is, but for a lot of the stuff in the book, I think the reality is like chapter part 1 is the most, in my opinion, the most complicated. And even in chapter 2, some of the linear algebra stuff, here, let me, again, I don't want to get in like trouble for just streaming the whole book. So let me go to a specific snippet that I think is somewhat complicated. Or it's definitely complicated. Towards the end of chapter 2, like the PCA stuff. If you're not familiar with linear algebra and all of this kind of stuff here, this is very complicated. But you can sort of, there's a, if you've worked with it, it's just not, it's the same with any math. Once you work with it for a while, it doesn't become so complicated. So when you see this VW lambda, W lambda thing, this is what they call a spectral decomposition, which is a very fancy way to, like, this is just one example. Let me go for xcalidraw, xcalidraw.com. Let's say you have some system where you have a couple of basis vectors. Let's say this is sort of like x and y Cartesian directions, and you have some basis vectors v1 and v2. And you have some matrix which acts in this space. So this could be a rotation operator, which has, some elements that rotate vectors. So, if you were to rotate this vector by 90 degrees, then to apply it to V1, then this would give you, V1 rotated by 90 degrees. So this would be kind of like rotation by 90 V1. So this is an example here. And when you see this spectrum, spectral decomposition, all you have to do for something like this is VW, where is it? First, we perform a spectral decomposition, VW. Where are we? Yeah, so these would be like the eigenvalues. So you can solve for the eigenvalues of any sort of matrix that's, well, not any matrix, but for a matrix like this, you can solve for the eigenvalues. And then this lambda matrix is literally just a matrix of eigenvalue of R1 and everything off diagonal is 0. 0, 0, 0, dot, 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 and dot, dot, dot. Eigenvalue 2 of R. I should probably have labeled it like this, but, and then dot, 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 and then the nth eigenvalue of R. And sometimes you'll sort them and everything like this. And yeah, a lot of it feels like it goes over your head, but once you apply it to a real problem, it becomes much more clear. So there are some scenarios where an eigenvalue is like a very abstract thing, but there are some things where an eigenvalue is a very intuitive thing. Like an eigenvalue, for example, if you consider like a rotation, consider this as like a 3D rotation. What's an eigenvector? An eigenvector, if we have some vector, which is, let's say, an eigenvector, and it's an eigenvector of this rotation matrix in 3D, all that means is that when you apply this transformation to the vector, you simply get a scalar times the original vector. So in other words, when you have an eigenvector of a matrix, let's say VE is the vector, all that means is that when we apply R to VE, we get some number, the eigenvalue, times VE. And what that means sort of intuitively is that eigenvectors, all that happens from them is they are scaled by whatever matrix they're an eigenvector of. Could be a negative number, so this would be like maybe E equals -1. Or let's say this one might be like epsilon. The eigenvalue is like 2 because it doubled the length here. This one might be the eigenvalue is -1 because it flipped it. And then you can think like what type of vectors would be an eigenvector of a rotation matrix? Well, if you had a 3-dimensional space, we have like x, y, or let's do x, y, z. Then let's imagine some vector which is just on the x-axis, right? I'm in chapter 1, so if you could explain how you would use an eigenvector in, for example, a model that you're making right now. Yeah, sure. So first, like, what is an eigenvector? An eigenvector is a vector, when you apply a matrix, all it does is it scales it up or down. So here's like a good example. So if this vector here lies on the x-axis, then a rotation around the x-axis will do nothing to it, right? So if we rotate around the x-axis like this, then it's simply on Vx, this will just be equal to, in our case, 1 times Vx. So this is a very specific case of an eigenvector where the eigenvalues under this matrix will only be 1. I created a model too, but I only use statistical probability and Bayesian updating. Yeah, so if you have this kind of like conditional probability that's always updating, how this would apply to you, it's a bit, it sort of depends on your implementation. But if you think about it here, what you do in this is you take the spectral decomposition. So let's like Google that. I think they have a good Wikipedia, spectral decomposition. So I don't have to type it all out. Eigendecomposition of a matrix. Basically, the spectral decomposition is it gives you a vector, a matrix of your eigenvectors. So usually, if you have some, let's call it A, and we do a spectral decomposition of A, spec decomp of A, then you get two things. You get usually a matrix, which is called W. I don't know if this is consistent with his notation, but this will be a matrix of the eigenvectors. So this would be like, something like this. This will be a square matrix, by the way. So this will be, say, n by n. I didn't draw it quite so nicely, but this is V1, V2, and then eigenvector n. And you'll also get this lambda matrix, which is also square, and this will be lambda 1, lambda 2, and also diagonal, I should say. Lambda 2, lambda n. Everything else is going to be 0. Not going to draw it in. I'll just do like this. And this is your eigendecomposition of a matrix. And so let me check if he is doing this consistent with the notation. I think he has it a bit different. I think, yeah, no, this is right. Yeah, this is the same notation I'm using here. So in this case, he's doing the principal components. So say you have a strategy where you have a portfolio of stocks, right? Or options, whatever, any sort of financial instrument. And you put these into what he's calling, let's see, let's just read this. Gaussian process characterized by a vector of means mu and a covariance matrix V. Oh, so this is not just the holdings. This is the covariance matrix. So this is how the prices effectively of the stocks depend on one another. Stochastic process describes an invariant random variable like the return of the stocks, changes of yield bonds, option volatilities for a portfolio of n instruments. We'd like to compute the vector allocations omega that conform to a particular distribution of risk across V's principal components. So in this case, V is, where are we? In this case, yeah, so this notation will still be good. V, you can think of it as, it's going to be like, the diagonals will be simply the variance of a stock. I'm not going to write this out, each one, but, and then the off diagonals will be a sort of correlation between the two stock prices. And so, and you can imagine filling these matrices out with the sigma ij's. So in his example, is that what he does? Does he talk about this anymore? Yeah. And so his question is basically, how do you pick the allocation here so that you have some fixed risk tolerance effectively? And so first you perform the spectral decomposition. What this does is it pulls for you the principal components. So it pulls, and the principal components are basically what they're calling the eigenvectors. So you pull the eigenvectors. And what are the eigenvectors? Those are just the things that when you multiply them by this matrix of covariances, it only scales your variable. What's the prerequisite to the topic you guys are talking about? Just linear algebra. You can just do, what's it called? What's that really good? Gilbert Strang, linear algebra. Yeah. So if you go to any of his books on linear algebra, can we do full screen? I don't know if you can see this. I don't know why this is so messy. So if you go to, let's see, if you get up to chapter 6 of this book, then that's all we're talking about. Only thing I know about linear algebra is y equals mx. Yeah, so linear algebra is like different from algebra. That's like algebra. Linear algebra is when you have sets of equations like that and you build matrices out of them. So like to chapter 6 of this book, you would understand everything. And this is just Gilbert Strang, Introduction to Linear Algebra. And that's for like a full, you would really deeply understand it. But you don't really, I mean, you could also just watch some videos about like 3 blue, 1 brown or whatever about eigenvalues and eigenvectors and transformation matrices and all of that kind of stuff. Because it's super applicable to pretty much anything you would do mathematically. And so in this case, we have this matrix of what I like to think of as, in a sense, kind of like on the diagonal, it's like a volatility, sort of. And on the off diagonal, it's kind of like the correlation of stock prices. So given a vector of allocations, we can compute the total risk as this omega v omega. And omega is your allocation of the stock. So if we, to give it like an explicit example, let's say we have 3 stocks. Let's say we have Apple, Microsoft, and Google. Then if you have $100 in Apple, 200 in Microsoft, and 50 in Google, then the total here is 350, right? I should have picked some nicer number to get percentages from. This would be, let me bring up the calculator. 100 by 350 is what? 0.28. So our omega in this scenario would be equal to 0.28. So this is 28% of your portfolio. This would then be 56. And then this would be, what would it be? 14 or something? 14%. Does this add up? 7, 8, 14, 18. I mean, so I'll just add in a 0.5 to these two. So this adds up, I believe, to 1, or close enough. The point is these should add up to 1.0, which represents 100% of your holdings, right? And so you have this vector of how you've distributed your capital across a set of instruments. And then in this, to just kind of determine the risk, I guess, remember V is your principal component. So that is when you do this spectral decomposition, this is your, basically these are like your W's in a sense. The columns of W are reordered so that the elements of lambda's diagonals are sorted in descending order. Yeah, so in this example, this would be your highest one. So this would be like 500. This one might be 20. This one might be 1.0. Typically, these drop off very, very quickly. And what this corresponds to in terms of really thinking about it is, so V would be a vector, or sorry, what is he calling it? W. The columns of W are your holdings. You can think of it like distributions of holdings. So this may be 0.8, 0.2, I don't know, maybe even a negative 0.3, and then 0.4. And this first eigenvector, when you sort it, so I should call this like V1, and then this is built out to have n eigenvectors. When you order them so that these pick out the highest eigenvectors, or eigenvalues, sorry, then what this means is if you change your portfolio along this direction, I should only have 3 because we did a 3 example. So in other words, if you increase your holdings in Apple by 80.8 and your Microsoft holdings by 0.2 and you decrease your holdings in Google by 0.3, then that will give you the largest change in these eigenvalues and sort of how you hit your risk, so to speak. So this orienting here gives you the most bang for your buck in terms of adjusting your risk in this very specific example. And so you can compute the total risk as these eigenvectors transposed and then multiplied by these things here. So I keep losing it. Let me put these right next to each other. So WT would be something like just one of these vectors sideways. So, you know, A1, A2, A3. This would be a 1 by n matrix. You take the matrix multiplication of that with the V. V is this n by n matrix. And then W not transposed would be the same thing. A1, A2, A3, and this would be n by 1. So when you do your matrix multiplication rules, the inside dimension must match, and the outside dimension is what you get as a result. So this first matrix multiplication would give you n by 1 again. And then this next one, 1 by n multiplied by n by 1, would give you these inside dimensions match, and these outside dimensions are what you get, 1 by 1. And so this just gives you a number. And this gives you some contribution to the overall risk, which we're calling sigma squared, or sigma, whatever he calls it. And the simplest way to do this is you can then write this V matrix. This is one sort of property of the spectral decomposition, is that you can write this original matrix as your matrix of eigenvectors matrix multiplied by the matrix of eigenvalues multiplied by the matrix of eigenvectors transposed. That's just a property of this spectral decomposition. So if you look it up, spectral decomposition properties, you don't have to take my word for this, but it should be. So here's the sort of thing. They use a bit of different notation. What we're calling W, they're calling Q. So the original matrix is equal to, by definition, this matrix of eigenvectors, multiplied by the matrix of eigenvalues on the diagonal, multiplied by the transpose of the eigenvector matrix. Okay, so this is just by definition. So we're not doing anything fancy from this step to this step, even if it looks complex. He's just rewriting V as vectors, values, vectors transposed. And then he's simply redefining our allocation vector, which is how much of each stock we have, multiplied by the matrix of eigenvectors. He's redefining that to be beta. Okay. And then what he's doing here is this is kind of like a factorization. So in the same way that you can write a binomial as typically the product of two binomials or something like that, this is like the matrix version of what he's doing here. And beta, then what is beta? If beta is defined as this, our allocations multiplied by this eigenvector matrix. I should have picked something better. Let's kind of draw these as very separate things. So if these are our allocations, in other words, how much of each stock we have, and these are our matrices of eigenvectors, so this looks something like V1 dot 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 Vn. Then what this does when we multiply this vector by this is it gives us a new vector. So if you look at the dimensions of this, right, make sure I have it right. Oh, this should be transposed, sorry. Where are we? I keep losing it. So this should be transposed, my bad. And this would be our transposed version as well. Like this, dot, dot, dot. So this is 1 by n. This is n by n. And so this results in, for us, a new 1 by n vector. That looks something like, you know, a vector on its side. That's how I like to think about it. And what is this? This is simply basically our allocations projected onto the eigenvectors. So you can imagine we have some, you know, complex vector in, let's say, 2D space. Looks something like this. This is maybe, you know, 0.7x. So the matrices are for risk management and portfolio rebalancing exactly. Yeah, exactly. That's exactly it. So you can think about it like um, when you pull those where is it? So when you do this projection here and use portfolio allocation as the risk factor, you use the variance of the instruments within the portfolio as the risk factor. And it's not really simplistic because the original matrix V is not very simple. So in terms of like the math, it is pretty simple, but in terms of it not being like a sophisticated approach, it is a pretty sophisticated approach because this V is builds a lot of good information into it. And how you get these sigmas, you could imagine requires a ton of data. So these individual sigmas might be the correlation of the stock price for each one of these over, a 20-year period or something like that. And maybe you weight more recent times higher than old times. And so there's a bunch of interesting stuff that goes into how reliable these sigmas are. But yeah, that's exactly it. So you basically pull your so the highest impact to the overall volatility is the eigenvectors of these V matrix of this V matrix, which is W. And then you can project your specific holdings onto the eigenvectors of this matrix, and that will tell you sort of what direction you can adjust each of these holdings in to get the desired risk. And then the total risk, if this if sigma I is something like omega prime W lambda W prime probably. Let me do this. Omega. And these are like your beta prime, lambda, beta. And this is lambda I. So this should really be like I. Then all you need to do to get your total risk is basically sum over these sigmas. And then because you have the adjusting of these sigmas with regard to your holdings, it becomes very easy to just shift your holdings a little bit to get the desired risk tolerance. So does he do this? Yeah. And so he's calling, I should have sigma squared. I guess these should be sigma squared. So all you need to do then, where does he have it? You can interpret R, which is B squared, beta squared times these lambda eigenvalues, multiplied by the variance, the total variance. You can determine these things sort of to be how much risk you have across each V, which is a column of this W matrix. And I guess my notation is a bit messy because he calls these things V. I like to call this original matrix A or something, but yeah, you got the idea. So this gives you a nice formalism to adjust your risk to some desired tolerance by simply shifting your holdings in these original omegas. And so it ends up being sort of some complicated math, right? But really the interpretation is not too complicated. And this is typically what you'll see. You should create a YouTube series playlist on the math in the book on your YouTube channel. Yeah, that might be a good idea. Maybe, yeah, we could probably do something like that. Maybe something where it's kind of we go over the fundamental math that goes into something like this in the first part of the video, and then go through a very explicit finance example. I think that's a good idea. So maybe I'll have to do that. Yeah, thank you. Because I think when you see something like this, it's very overwhelming if you're not used to working with matrices. But when you really break it down step by step, the information you get out of it is pretty intuitive, I think. So yeah, I'll probably try and do something like that. I'll have to find the time to make the videos on it though. And so we have this, yeah, and so that's pretty much it. Yeah, and if you have, and the other thing I was going to say, so the eigenvalues of these, very roughly, will correlate with kind of the magnitude of these components, is how I like to think about it. So in most scenarios, there's one or two or three of these vectors within W which I called V, but he calls, I don't know, something else. Maybe R. No, he never calls these anything specific. But the columns of this W matrix, you can think of as adjusting your risk. And then there will always be a few of them that will adjust your risk way, way more than the other ones. And so that's how I like to think about it. You explained pretty well. Thank you. Yeah. Well, I've worked with this stuff for kind of a very long time. So my background is it's in physics, but a lot of physics uses this exact same type of stuff all the time. So yeah, for sure, I'll make some videos on the math of this kind of stuff, and maybe as I kind of want to make it, I want to try to make it kind of like broad appeal. So I want to think of examples where we can take this math, which many people are just disinterested in, and very quickly apply it to something that people care a lot about. So I'll have to spend some time thinking about that. Because even like if you're serious about this stuff, like if you're reading the book, you're serious about it, right? So you care about risk management and all of these things, but your average person, I don't think, cares too much about risk management. So finding a way to apply this to something where it's like, here's how you could literally make money off of understanding these things, that's something I want to think a bit more about. Because yeah, the day trading space is, of course, filled with people who their goal is to maximize this number here, not to minimize it while maintaining some decent returns. So, yeah, it's kind of just one of those things where you have to balance the technical stuff with also keeping it somewhat interesting. Yeah, and so now this is back to this OHLC thing. I suppose this is working now, I believe. And so I was thinking of when we remove this, all of these extra columns. Where was it? Oh, it was in the Jupyter notebook. So when we remove these columns, we go from a messy thing like this to the correct candlesticks, which is good. I'm not sure if I want to trash all this data though. So I was thinking of having it handle this by itself, but I think it's somewhat like this data is not invaluable because this shows you how the candlestick was changing over the minute time frame. So I don't want to trash this. What I think I want to do is load it in a way where we handle this. So let's have an option to do this. If remove duplicate, how would we phrase this? Let's say if remove, we're using Jupyter instead of, because you just get quick things. You don't, if you want to run this in a Python script, you have to reload all of this relevant stuff each time and wait for the plot to pop up and all of these things. So, I mean, we're using, to edit the code itself, I'm using NeoVim and VS Code, but for visualizing things, Jupyter notebooks are nice. So if remove duplicate timestamps, then what we'll do is this, and I think we just have to pull pull the last one? Dot last, I think. We'll be able to see pretty much immediately. If remove duplicate timestamp, oh, right. Let's for now just set it to true rather. Okay, so this looks like it did not quite work. df.group by tend last. Maybe we need to do this index setting first. Okay, so what's going on here? Let's print the length of the data frame before and after this. Print len df. See if it's actually trimming anything. Okay, so it's not trimming anything for us. df group by end last. What did we do here? Oh, right, we're not resetting the data frame. So df equals this. And now it works. And so our start time is what, 2022. End time is 126. So how many minutes are there? That's what, 2 hours and 4 minutes? Feel confused on Jupyter? Yeah, well, it is I wouldn't recommend using it. Like if you're first starting to use Python right now, I wouldn't recommend using it too much because it's one thing that's very, very confusing about it is it feels like you're running a script, right? So we can comment all of this out right now. And if this is a script, df is not defined, but I can comment all of that stuff out and then do df.head, and it's still stored in the sort of Jupyter memory. But if you run this as a Python script, this just tells you df is not defined. So if you're using Python for, if you're kind of new to it, I wouldn't recommend relying on Jupyter notebooks too much. It's a bit messy. You're from software development background. Yeah, so exactly. It's like it's a very confusing thing because like the state of the program is not what you would expect from the code. But for data science and kind of stuff like that, it's super useful because quick visualizations, you can modify your data, and then it's always a good idea to take this stuff. So what I do is typically we build out this kind of stuff in the stream, and then what I do off stream is I bring it and put it into the code in a more permanent format, which is a bit tedious, but maybe it's worth it to show some of that on stream. We'll do that some of that today because I want to have this set up to kind of work with the code. Okay, so this works for us. Now let's test if it works when we bring it back to run our bot from yesterday. So yesterday what we did is I'll show you this. So yesterday, and another annoying thing, PyCharm works good. Yeah, I think you have to pay, I believe, if I'm not mistaken. Is it? I may be wrong. But I did think, is it not paid? I used to use PyCharm a lot, but I think I'm not like a student. I think they might have a student version. But as of a few months ago, oh, Community Edition is free. Okay. PyCharm, JetBrains. I like their, what's their other one? I liked one of theirs for this IntelliJ. Is that theirs? Because I used to do Java. Is IntelliJ them? JetBrains. Yeah, it's theirs. Yeah. I used to use this one for Java. And that was kind of like before. Maybe VS Code was a thing at the time, but I don't. It wasn't very popular. It's crazy to look at the editor popularity over time, like a code editor popularity. It's insane to look at how much VS Code blew up. Yeah, I think it's much better for. I think it's much better than VS Code, that's for sure. Do they not have? I thought there was one of these things where they have like the popularity over time. So like VS Code is totally blown up. Where are we? What year is this? 2019. Wow. I didn't. So that's like 2019. Ready? Look at something more recent, probably. Let's see, like 2024. It's insane. VS Code is just like completely dominating now. Visual Studio Code in 2024. Can we get this in new tab? Like it went from pretty even with the most common things. And then we have this. Well, VS Code is an IDE too. It has all the things that IntelliJ and all of those have. It's just not as nice. The good thing about these JetBrains editors really is that they have, it's very language specific. So VS Code is a bit general purpose and it's kind of complicated to set up things for your preferred language. But yeah, I'm not really big on VS Code either. The only reason I'm using Cursor is because of the IDE. Yeah, exactly. You really need to build out the IDE functionality yourself. The JetBrains editors, IDEs come out of the box much more configured for your language. But I kind of like configuring myself, so I like to use, this is why I prefer NeoVim, but it's kind of not super stream friendly, so I just use this. especially because I like to use multiple languages. Everything we're doing on here is Python, but I like to use multiple languages. So the editors that are flexible to that are useful for me. So we have this. Let's try to double check. Okay, so what are we doing now? Let's test the live model. So when we pull our live data here, we have something like this. Let me clean up some stuff. So let's first, actually, you know what? Let's clean up some of these files. So we have this data we don't need. All of this we can get rid of. Delete these. Within the web app, what do we have? Data.csv, let's get rid of that. Keep our example scripts. Script.js, and this we need. Does Kraken give free live data? Yep, yeah, completely free. If you want tick data, you need to provide like API information, but it's all free, yeah. The name is Kraken Pro, which makes it sound like it's paid, but I don't know why they named it that, but it's free. So cracked egg info, we don't need any of this. These ones are from Pandy in the Discord, so I'm going to move these to, let's organize things in a way where everything is where it should be. So let's make dir testing data. And then let's move our Bitcoin 5-minute candles to testing data. Move our gold 5-minute candles to testing data. And let's see. Let's remove test. Let's see what's in test.py. And we don't need this. Remove test.py. Okay, so this is looking a lot more clean now. These two I can't do anything about, even though they're messy. They have to stick around. What else do we have? Let's go to examples. Let's remove some of our data here because this is a bit of a mess. So we have some notebooks which will stay. Python scripts can stay. And actually this is a pretty clean folder. This folder is a mess, however. Let's remove all of our CSV files. That cleaned it up a bit. Let's remove our TXT files. Let's remove these Kraken test. Oh, I spelled it wrong. Kraken test and Kraken tick. Let's remove both of those. Oh, I vimmed them. Whoops. Remove. Let's see. Remove testing. Remove L1 BBO.json. Remove process. We might want this one. L2 orderbook.json. And that's pretty much it. And let's move all of our notebooks here, untitled, to our examples folder. And now this should be, let's do a little git status. Let's add some things. Let's git add our readme. Git add feeds. Git remove Kraken test. Git remove Kraken tick. Git status, and let's call this just clean up main folder and update to readme. Okay, so that cleans things up a little bit. Now let's X out all of this stuff. Let's actually leave this one open. Let's X out our testing bot. Save it though. And these we will leave open. So let's do a little refresh and see how things are looking. So in cracked, now all we have is some data. These things are git ignored. And then we have the 4 main files. Within our web app, we have just the main file. We should move this data read. Data read to our examples. And then we should really probably move. Let's go back to the web app and let's make something called minimum web app example. And let's move our py files, except for app.py. into our minimum example. Move L2, move test data to minimum, move OHLC to minimum. And now this is a clean directory, so we can do a little update here. Git remove L2, git remove OHLC, git add minimum web app examples. We should have all these new files that got moved into here. And I think our app itself is fine. Git commit update web app. Let's just say cleanup folder. Nice. Is it required to SSN to access? I don't know that. I made my account a long time ago. I assume if you're in the US, yes. I would assume. But if I recall correctly, there is, like, if you don't have an SSN, or if you're, I don't know how that works if you're, I don't know if you're saying, like, you don't have an SSN or you don't want to provide it. I think for people who don't have SSN, there was some other option, like if you're from a different country or you're here temporarily or whatever. I thought there was some other thing you could do. Yeah, I just saw your message. Sorry if that was sitting there for a while. But I believe what you can do is you definitely have to provide some sort of tax info because they have to report all your earnings. But that's any crypto exchange if you're in the US. I have it, but they're asking full SSN. Yeah, well, you would need to provide it. That's going to be the case for any. If you have one, like, and you're able to do this kind of stuff in US, then yeah, you would have to provide it. But the nice thing is they send you the tax form to just, it's very easy with your overall earnings and stuff like that. Is Kraken safe? I mean, I use it. I've never had any problems with it, but I don't have, like, I know some people are very concerned about that kind of stuff. I'm not really so concerned about that kind of, like, identity theft. I mean, I'm not concerned about it with Kraken. Because to trade crypto on any of these things, if you're in the US, you have to provide this SSN info, as far as I know. Because it's all taxable events and they're forced to keep track and report that kind of stuff. If you're concerned about it, you could try a more popular one. You could try Binance or something like that. So we have this. Wait, what's it saying? Do I have this open twice? Can I just save this? Overwrite. I just overwrote it. Oh, shoot, that might get rid of some of these changes within the OHLC, but it's okay. Not too worried about it. So let's now check that this works. Okay, so everything here should be up and working now. So we go from 1400, so we get on average about 6 pings per minute. So it's roughly a ping every 10 seconds, I guess, with the updated candlestick information live. And then we can get rid of all this. We don't need this anymore. So yeah, we're pretty good there. So I think we're actually good to fix this now. So the problem is not really so much in the code. The problem is in how we load the code. So when we have our live trading bot, let's X this out, testing bot, the IPINB. How do I get API key? Here, let me, I don't want to leak my API key, so let me throw this be right back thing onto the stream. So if you go into settings, yeah, go into settings, API, and then you can just hit create API key. And then you can set what you want to do with it and everything. So if I were you, I would turn off deposit and withdraw. so that if somehow you ever accidentally send someone a script with your API key in it or whatever, then, all they could possibly do is make trades on your account and troll you. So this is still not good, but it's much less problematic than them being able to withdraw all of your balance. But yeah, just go to settings and then API. So I can unhide the stream now. Let's go for, how do I click? There we go. So this is back to my account. And I'll click over here or something. Yeah. Now, oh, you got it. Nice. Yeah, I think it only takes a little bit. Only query for data good. Yeah, that's fine. If that's all, unless you're trying to execute trades. If you want to make trades live, then yeah, you would need to, I think there's two options. You can add and cancel orders, I think are two options, something. So can you maybe explain what indicators your trading bot uses for its trades? Not necessarily the MACD, but what prereqs it needs for a buy or sell. Yeah, so I mean, I build, no, I don't use only market data. So I have, maybe I can show you. One of my packages is a big, they give a simulated accounted SDA. You can mess around with paper trading on there. So if I do, oh no, let me go to new Dolphin. Let me open up a cursor here. So with this one thing that I like to build into my models is sentiment. Maybe less important for traditional financial instruments, but for crypto, obviously, like so much of crypto is just honestly like nonsense hype, right? And so in my Dolphin code, I have this sentiment folder, or I have it all in the ML folder for now. And basically, I have like a couple 100,000 tweets. And I train one of these. I need to update it because the current model is not as good as I want it to be. But if you look, I use one of these Hugging Face models. Hugging Face, I use the BERT sequential classifier, I believe it's called. Sequence classifier, maybe? Sequence. Yes, BERT for sequence classification. And what I do is I take their base model and I fine tune it to a bunch of financial data that I have from Twitter. So I need to pay someone though to label all of this new data I have. So with like 5,000 tweets, you can get 80 to 85% accuracy. And these things typically scale somewhat logarithmically. So to get, 90% accuracy, you'll need 50K tweets. And so I'm targeting like 95% accuracy. And yeah, it's from Twitter, yeah. I will not maybe show how I get the data from Twitter, but it's from Twitter. And yeah, it's tough to, I mean, like scraping tweets is not illegal, but they can ban you for it. So you need to find a sort of way to do that. And if you just copy some person's way of doing it, it gets detected and banned pretty much immediately, which is very annoying. But I can show you, like, in some of these models, I can show you one of the, I mean, here's kind of like the distribution of my labels. This is neutral, positive, negative. Here's one of my training. I'll just show you some of the training statistics. Where are they? Where's the one I have with all of them? Model training. Here we go. Here's like, I just did a very random hyperparameter scan. And in the logs, epochs, where is it? Where's my thing with all of the... I thought I had in here. Here's some of them. These are not any of the really good ones, but training accuracy very quickly. So when you do the fine tuning on these things, you only really want to go like 2 to 4 epochs. And you can see why here. You basically immediately start overfitting against the new data. So my training accuracy ends up, up to, you can get the training accuracy arbitrarily high, of course, with the complexity of the model and the amount of data. But in order to keep the validation accuracy high, the highest I have is like around 80 to 85%. So not in any of these, but some of these. So this one's a little bit better at 60. This one, roughly around here. And this is on some pretty low quality data. So if you use just their base model, it's pretty garbage. But yeah. What's the difference between getting signal from social media and level 3 data? Well, I think it's good to combine the two. So that's the other thing. So I use some sentiment in my models. I don't have any really good, I'll be honest with you, I don't have any great models right now. I've been kind of focused on developing the codes here so that I can build much better models. But I don't believe in really using price data too much. So I think, yeah, the level 3 data is where the money is, and to some extent, level 2 data is good as well. I think there's very little value in L1 data. I just don't believe that these kind of like chart analyses are effective. At least they're not effective on their own. They may be useful in conjunction with some other more complex strategies, I guess, but on their own, I don't think they're too useful. So yeah, I use a combination of L3 data, and I like to use, if you read that Advances in Financial ML book, I have, I can show you in my bars, in my L3 bars, basically I have all the different bars that he talks about in that book: volume, dollar, tick, imbalance. And they're not too complicated to implement, but they're tricky to get right, and they're tricky to get fast using pandas as well. So some of them, like the tick imbalance bars, these are pretty complicated, and I still think it's a little bit buggy. But what I like to use is some combination of quote unquote price data, typically out of these dollar bars. I think these are the best aggregates you can possibly use. And then over these time frames where we aggregate the dollar bars, I also like to look at the imbalance. So this is kind of like when you have a large imbalance of buys or sells. I also like this Q sum filter that I have in labels, indicators. This Q sum filter is very good at showing you when there's been a large price run as opposed to a large run in, buys or sells. These, you would think they maybe correlate, but they really don't. Sentiment analysis. And then it's really a game of building interesting features out of your aggregates from there and trying to do, and of course I use all sorts of risk stuff for analyzing rolling volatility, relative volatility, correlation between different instruments. Like, so for example, one thing I'm very interested in, which we'll probably do a stream on once we have the cracked package done, is getting a huge amount of historical data. Where's my Excalibur? And if you have, Bitcoin, you use that as a proxy. You also have indices for crypto, like VIX, I think it is, right? Or is VIX that might be the total stock market one. What is a VIX? Symbol. What's the word I'm looking for? Index. Yeah, this is not it. What's the crypto? I forget the name of the crypto VIX. BTX or something? Crypto VIX analogy. Yeah, so I mean, they have all these different indice metrics for crypto volatility. I'm interested in these. I forget if it's this, whatever the name is, I forget. BTC, and let's say whatever coin you're targeting. Maybe it's Doge or something. Something I'm interested in is building out this kind of correlation between these three and seeing if there's any precursor in terms of price data, in terms of Twitter sentiment, in terms of these volatilities, seeing if there's any precursor to regions where they are decorrelated. This is kind of what I'm interested in. So can you maybe predict a sort of indicator, not like a technical indicator, but some sort of signal that indicates for you these are about to be very decorrelated. Maybe this coin's going to go down while these ones go up. That's something I'm interested in, really building out a solid thing for. Have I used bookmap, heat map for trading? I don't know what bookmap is. I've never heard of it. Bookmap, heat map. So the opposite of pairs trading. Yeah, basically looking for like an anti-correlated pairs trading type of thing. Heat map and trading, how to learn what market depth is hiding. I've never heard of this. Price charts versus heat map trading. Large number of limit buys. You don't really know what I'm looking at here. So what do the colors of these squares mean? Is this like your, where are we? Oh, these are, oh, okay. So this is like the, oh, so this is like the L2 data as like a heat map, basically, right? Is that it? Basically, market order pending a different price. Yeah, yeah. Okay, so, okay, yeah, interesting. So I do have the L2 that I also do use, yeah. I haven't worked it into any models myself personally, but I do think there's definitely some good stuff to do there. And, really what I think I'm interested in looking at with the L2 data is the not necessarily like snapshots of it, but the change in it over time because it changes so quickly that if you can, that any sort of like rolling average of the volume at a price level seems very useless to me. But there has to be, excuse me, there has to be some way to extract value of these price levels over time and correlate them to price movements. So all these things are, there's so much, that's what I like about finances. There's just so much data, and it's really a game of finding like what data is valuable and how can you transform the data to get something unique that really only you have access to. And that's why, of course, the quant space is so secretive because you can just have a clever idea and find something that no one else has really thought of. And if you can do that and keep it for yourself, that's a really valuable thing. That's also the reason I'm a bit hesitant to accept a quant job if I end up going for something like that. What are my thoughts on reinforcement learning? I mean, I know people use it. Some people use it, but I'm not necessarily convinced that it's the most useful for trading. I'm not an expert in it by any means, but when I think of reinforcement learning, I think of, a sort of almost gamified scenario where you have like some agent, you have some policy that it acts by, reward, and you have some kind of feedback loop. And obviously, there are a million ways you do this, right? And you can modify the policy as well. And you can obviously modify the reward as well. But very roughly, this is like the most general form of it. You have some agent which acts on some policy and updates how it acts depending on some reward function. I'm not convinced that this is the best way to do it because I think deterministic, I mean, you could say this is deterministic, but I think that I think traditional machine learning is just much more well suited to this because I don't really think of price prediction as a sort of game where you can take, the information in this window and use it to select a different course of actions that will lead in higher returns. And I know that there's a lot of complex stuff that goes into what people use as the reward function for reinforcement learning. So I'm not saying it's not good, but for me, someone who's not an expert in it to begin with, uh, it seems like a lot of effort for me to become somewhat of an expert in this for what I don't really think is going to be the best approach. That's what deep RL is for. Yeah, the problem with just adding complexity to the model, though, is you lose explainability and also you tend to overfit much harder to historical data. Yeah. So you can of course plug in neural networks or something to anywhere here to adjust the reward, to adjust how the agent carries out policy and stuff like that. But I guess for me, it's like, why? Why would you do it? Why not just use this kind of data in a much more explainable way? That's what my sort of thought on it is. It may be the case that it's useful, but it's not something I will look into. I don't think. Just because it's so much time to come up to speed with these kinds of things that, yeah. And these models that are, just more traditional ML based work for me. So until they stop working, until I have like a good reason to look into those, I probably won't do it too deeply. Maybe we can do a stream or something where we do it for fun. Look into it, read some papers on it. I've read a couple papers on reinforcement learning in finance, but they seem to say the things that I'm saying, which is that it's not obvious there's some large benefit to doing reinforcement learning over more traditional machine learning. Yeah, so we have this. Okay, so I'm going to try to, let's try to get the live model up and running. Or let's at least have the live model pull the correct data. So let's spool up a thing here. But coming back to the idea you got in a model, I created a model that looks at the percentage of change of some factor and the percentage of change in some probably target variable in the future by creating bins to find correlations, but you can look for the opposite. Yeah, so how does your model have access to this future data though? In a live trading setting, I mean. Or you mean you are, oh, so Y is like your targets. I see what you mean. So you're like training on some targets, and then hopefully your model takes these X factors and is able to predict those price movements in the future, I suppose, is what you're saying. We had a similar thing going in the machine learning stream the other day. Basically, what we did is we took just as a simple example, we took our features as recent price history, volatility history, returns history. And then when we were trying to predict this triple barrier method hit as the target, so this would be like 0, 1, and this would be -1. And so these were our YIs that we predicted, and this historical data here was our X's. And so it was just kind of like, yeah. And we tried a bunch of different ML algorithms to predict these. I used only very little data here, though. You said you're new to this. Now a model. Oh, wait, let me see. No, I'm looking to increase the probability, not per se a model, but I'm new to this. Yeah. Yeah, and I mean, when you have the ML probabilities coming out of one of these models, like typically they come out as a number, right? So it'll be 0.3, 0.2, 0.5, and you take some sort of max of these. And that's your prediction, but really these you can think of as the model's certainty in some specific classification task. So you can kind of get a pseudo probability from the model out of that if that's what you're interested in. And it's useful. But how useful it is, of course, depends on the quality of the data. So where are we? Troubleshoot. Let's try and get this working, not this testing bot. Okay. So we read in our OHLC data. If the thing exists, we read this. If it's not empty, then the latest trade is this. But what we now need to do is we need to say, whoops. Oh no, what did I do? What did I do? We need to say df equals df.group by tend last. Okay, try. Then we have our executions for the cracked package open up. While true, check and execute. Let's turn off all those prints in the OHLC feed that I added. Oh, I removed them. Nice. And then, yeah. Time sleep. So we sleep. We don't need to sleep so frequently because we're getting new data in the data frame. This is super inefficient. We reload the data frame every single time. But yeah, oh well. Now, I suppose we should probably return the data frame here. Let's do return df. Data frame equals, nope. So our read in new data should simply be this, right? Df equals check and execute. This should not really be called check and execute. We should call this load new data. Load new, well, let's call it load live data. I don't know if my A button is broken. Load live data. And yeah, so it's all hard coded in for now. Let's see if this works. So we do, let's not have this happen. Doge holdings equals get balances. Sure, we can do this. Current price Doge holdings times BBO. And then these will be, we'll comment these out for now. This is more once we have everything working. Let's first check that our data is loading properly. API key is not defined. That's okay. Actually, no, it's not okay. Where do I have the API key? If name is main, I'll just copy this in. TradeBot data feed, testing bot. Okay, we have this. Okay, so this seems to be working. However, let's go ahead and visualize the bars whenever we load them in. So let's do visualize bars df. Now, problem is I don't think I have that imported. So let's do from dolphin.bars.l3 import visualize bars. And I guess bars, this visualize bars function should probably not be in the L3 data. Should be fine. So we come in here, we wait 10 seconds. Okay. Visual Xi bar, that's why. Hold on, let's put the sleep after this so that we don't have to wait immediately to get errors. Conf columns, expected. Oh, we have to, oh, that's so annoying. Let's do this. This is something I will clean up so that when we write the data and try and load it into a data frame, oh shoot. So when we write the data and load it into a data frame, we don't have to keep doing this re-indexing thing. What's the problem now? T-end. Above gear T-end. Why? Load live data, bot data OHLC.csv. My VS Code is so messed up. I don't know what's up with my... Dude, what is going on with my key bindings right now? So let's grab this. It's not letting me copy paste. What is going on? It's weird. It's like Vim mode is just not working. Can I copy like this? Might have to restart my... I just cannot cut and paste. That's so annoying. Why can I not? What is going on? I'm about to X this thing out and restart it. Save this, exit out, exit out. TradeBot data feed, testing bot. Is this going to work now? Okay, it's working now. Yeah, this is why I'm not too big on these bigger code editors. I always run into these problems. Okay, so we load in the data, but this pre-processing should happen in here. DFT end, pandas. Let's print the head of this data frame though. Print df.head. Oh, this group by I think needs to happen after all of this. That might be it. Let's delete this. Let's run this. Okay, here we go. Now it's working. And this should update every 10 seconds, supposedly. And let's have it only plot the, oh, but I don't have the data feed reading. Or running, I should say. Let's do LSRHLT. Go to cracked. Examples. Do we have the OHLC example? Where do we have the Vim trade bot data feed? Okay, so let's do this. Let's remove the file in there currently. Data, no, bot data. OHLC. And let's run a feed here. Let's run a trade feed for the OHLC data. Connection opened, so it should be writing. So let's double check that we have a file in there, bot data. ls RHLT bot data, tailf bot data, OHLC. Let's see if it's updating. I'm not in love with their historical feed where they just like don't give you all of the timestamps or every minute. It's very strange. So we have this though. Well, so our most recent thing is there's 142. We'll check back here in a second. Now let's try running this. Here we go. So now it's loading in the data correctly, it seems. Let's check against cracked. What am I talking about? Check against Kraken. Come over here. Let's zoom in. We're on, what are we on? 1 minute? Do we have the correct data here? Looks like we started around here. So we started here, here. 1, 2, 3, 4. Oh no, we started here. We started right here. So let me, so it's not confusing for me. No, we started here, sorry. This bar, here, here. I'm so confused. I don't trust their data coming in. Oh, it's because they missed a minute for us also. Like it seems correct most of the time, but what is going on here to here? Yeah, I'm not in love with their data. At least for the candlesticks. This should be updating every, let's update this more frequently. Also, let's see if we got any new data. We've got some new data in here. So I want to see one of these update live. Should be running every 10 seconds, right? Yeah, every 10 seconds. We load in the live data. Let's do a little print when we do this. Print, reloading, live data. Let's also compute an SMA, I guess. Well, let's first check that this is working. Reloading live data. Okay, so it is doing it. Is it as flat as it seems to be for us? Yep, it is. Let's zoom in on the price level though. So that it's okay, too much. Zoom in a little bit on the price level. So we got a new bar there. Did we get our new bar? What's the most recent bar? 2040. Oh no. There's just like no price movement, I guess. Maybe it was a bad idea to do this with something with so low volume like Doge. Yeah, because like, look, The volume is like 1,000 Doge. Let's go ahead and swap to Bitcoin. Remove bot data, OHLC. And then in here, let's pull some more. Vim trading, bot data feed. Let's go for Bitcoin USD. So, and then let's, oh, I didn't do this. Remove bot data, OHLC, Python. This is where we're monitoring the feed. So let's go ahead and let's just run these in the same window, so it's not so confusing. We can tail the file here, bot data ohlc.csv. And these are coming in every minute. So I guess Doge is just too low volume. So let's run this now. Let's swap over to Bitcoin. Bitcoin 1 minute candles. See if these look reasonable. They don't really look that good to me. Where's our price window? 7.5 up to 90. 7.5. Oh, so we're not zoomed in anywhere near enough. Why? How do I, wait. 8680. Their lowest is 8675, so let's make that our lowest. Right around here. 8675 up to, or sorry, 8700. So let's zoom in a little bit more. And we have it like this. Okay. So these clearly look correct now. We're just getting the data in a little bit slower, it seems, which is the cost of doing business when you have such long intervals. So they're huge here. Why is ours not live updating though? Let's have it update. I'm going to make it update like every 5 seconds. Or let's go every 3 seconds. So it seems whenever I rerun this, it updates with new data. Even sometimes faster than theirs. Like we're getting this data in pretty quickly, but the reloading is not happening. Let's get a count in here. Let's say something like count equals 1. Reload, and we'll just print the count so that we have an idea of how frequently it's, or how many times it's updated, because I feel like it's not updating properly. So like we should already have hit reload live data 2. So why is that not happening? Yeah, so it's not updating. While true, we come in, print this, df load data, visualize bars, time sleep, and that's it. So why? It should be coming down here, hitting the true again, and then being good to go. It may have something to do with this. I think this might be making us hang. Reloading live data 1. Okay, so why are we not doing this? Let's also try getting rid of this try except logic. So the whatever you call the code guy, one of these little AI guys wrote this code. So I'm not exactly seeing where the problem is. Because this sleep should be having us sleep 3 seconds, come right back in, reload the data. Oh, oh, whoops. Count plus equals 1. Let's try that. So a little restart here. Reloading live data 1. So it's still not happening. Are we keeping in sync with the exchange though? Yes, we are. Their scale has just changed quite a bit. the color of these bars when there's basically no price movement. There's a bit of a discrepancy there, but um, yeah. Yeah, so this is working, but I have to keep rerunning it to get the updates. So as soon as we rerun, we get an update. Why is this not updating? How about forget this? Let's do for I in range 100. Let's print I instead of count. Oh, let's call it count. Oh my gosh. It's just doing this. That's so annoying. So it is reloading them. Is there any way to, maybe we can we do something like, can we do something like plot that figure 1? Will that fix it for us? So we keep overwriting the same plot. Expected indented block after while statement. Oh, sorry. Yeah. Expected, here, we can leave the while true, I guess. We don't need this anymore. Plot is not defined, of course. Import matplotlib.pyplot as plot. Why does it keep doing this? Let me go to my visualize bars file. I'm going to interrupt this so it stops plotting. Visualize bars. Here, we can use matplotlib finance for now. So let's go ahead and do from MPL finance import. No, what is it? How do you import MPL finance as MPF? Yeah, that's the way. Typically, you want to do it. And then let's go mpf.plot. Can I get the docs on this? No. Can we do like figure? Can I do something like this? Equals fig. I just want it to stop overwriting. Or I want it to start overwriting. Okay. Fig equals this. Let's look up the documentation for matplotlib finance. MPL finance. Come in here. Examples. Hollow and filled candles. Just take a peek into their docs. Oh, these look kind of nice. How about you show us how to do it? Okay. Okay, this is terrible. Let's just go into their code source. Plotting. Where's the plot function? Def plot. Here it is. Okay. Where can we pass in fig? Is that not in the config? Is that not allowed? Can we not pass in the axes or the figure? I really hate when codes don't document like the optional things. There has to be some config documentation. Please tell me it's documented somewhere. Okay, so we just have to read through the entire code base. This is like, here we go. Axe. Perfect. Hello there. It's up fun only. We are trying to troubleshoot some plotting things. Let's try axe equals axe. What is it? Fig axe equals, can you do plot that subplots? Is that going to work? No. Subtitle. Ugh. None type object. Let's print out fig and ax right now. Print fig, ax, figure, axes. So it is how it should be. I guess they have a bug in their code. Fig dot, oh, it should be set subtitle if you're dealing with axes. Someone needs to make like a really good plotting software for this kind of stuff. You know what? Let's go ahead and tell the code to do it. Let's tell it to do it with Plotly. Okay. Write me a live updating Plotly OHLC v plot, I guess, using the data in df. See if it can handle it. See if it works. Okay. But is it going to live update? That's our question. Or is it just going to create a new one every couple seconds? Let's also go back to printing out the count. That will tell us immediately. Let's say print count. Count. Okay, not printing the count for us though. Or is it? Load the data. Where's our count? Is this really how the bars have been looking? Oh, it actually is. Very flat, and then this. Oh, nice. So it is live updating. Perfect. Finally. It's even updating faster than theirs. Let's keep them a little side by side, see what it looks like. Can we zoom out a little bit? There we go. See who gets the updates first. Keeps resetting on me. See if we get the updates first. Where can I put this? Let's see. Very slow moving symbols today. I guess it's a Sunday. Sort of to be expected. Yeah, we're getting them at like the same time. All right, good. It's good. Good enough for me. So now let's go ahead and add in the simple moving averages. So this is where we are sort of gearing ourselves towards building a live trading bot. Of course, you would want to build it with much more complex things than just an SMA crossover, right? But nonetheless, once you know how to build one for a simple SMA crossover, there's no additional complexity to doing it with something else. Testing bot. Oh no, where's our wait, where's all the additional code in this thing? Oh yeah, it's here. Do we have an SMA function? Comparison, blah blah blah. Crossover. Where do we compute the SMAs? Control F, SMA. Okay, here we go. Bring these in. Let's go ahead and compute these. Again, this is a super inefficient way of doing it. In the real thing, we will code up, just a simple update to this kind of stuff. And we definitely don't need to be importing these things in the loop. That's very silly. Let's go ahead and compute all, or rather import all of this at the top. And we will probably build out this live thing and then call it a wrap for today. So we compute out our SMAs. Yep. Now let's check for crossovers. Crossover this. And this updates in place anywhere we have an SMA. So let's also tell it to add, let's say, add the SMA 10 and SMA 30 to this data frame, but also add in any of the crossovers and be sure to make the labels look nice. Where are you writing and running this code at? Oh, you mean like the editor? Or do you mean like where am I from? Quite new to coding. This editor is called Cursor, and it's basically a spin-off of Visual Studio Code. So I don't know if I'd recommend this. I would recommend a terminal-based editor to someone who's new. So my go-to editor when I'm not on stream is called NeoVim. Has a bunch of nice things, your recent files. You can I'm pressing GD here, and then it will send me to this file where this thing is defined. You can do Control O and Control I to jump back and forth. It's super nice. Maybe I would, if you're super new, I would get, maybe use something like a VS Code just for a little bit until you get used to it. But what I wouldn't do is I would not use one of these super AI heavy tools if you're brand new to coding, because you can become very, very reliant on them. And it can really sort of, the most important thing when you're new to coding is really thinking through the problems that you run into, thinking through the errors that you run into and stuff like that. And when you use one of these AI editors, I even feel it myself. I've been coding for over a decade, and it just totally interrupts your kind of chain of thought when you use one of these code editors and it's constantly suggesting you things. So yeah, VS Code's a good one to use. And this is pretty much like VS Code. It just has some additional AI stuff, which for me, like one thing I don't really care about is being super good at writing plotting scripts and all of this. So I'm happy to let the AI handle the plotting for me. Nice. And so this is working for us. Let's add a few more SMAs. Why not? Let's throw in how do we want to do this? Let's add in like a lower SMA. Let's add in like an SMA 2 and an SMA 5. And then probably we can add in the traces for SMA 2 and 5. Let's interrupt this. So what language are you learning? Are you learning Python, I'm guessing? Well, let's maybe make the colors not so messy here. We'll go for black. And how about green? Interrupt this. Yeah, perfect. And let's compute the overlap, or rather the crossovers between 2 and 5, just to see if it's working. Where do we do this? Let's do, for now, this is a crossover strategy. I mean, it's not like actually one I would ever use, but we're just using it as something where you can get quick indicator. So like the things that I use that would actually generate signals are not going to generate signals fast enough for us to do this on stream. But for SMA crossovers, you can very easily get signals within, a couple of seconds. What is this? Oh, so it's claiming there are crossovers here. Okay, so this is working. I don't like this necessarily. I would never use SMA crossovers as a strategy, so I don't really mind. EMA may give you a faster result. Yeah, true. It would, definitely. Here we're just using the SMAs, but we got some already. So these, I don't like these triangles though. How about we do, let's make this like an X. Interrupt. And then we'll run it. Yeah, I think this looks much better. We should have different colors though. Oh, why are they not the... Crossover buy, crossover sell. These should be different colors. Are you trying to build a platform for visualizing real time? Not really. Like I already have one. I don't know if you've seen the app, but the app visualizes real time pretty decently. Cracked web app. So this thing does visualize in real time. More so, I'm just trying to get a rough visualization in real time right now so that we have trying to get a rough visualization now so that we have something that we can kind of check if the code for our strategy is making sense. So let me paste this in. And you can see, oh, I deleted all the data. So there's not going to be anything here to plot. But yeah, I have a live visualization thing. And then, yeah, so now I'm just trying to make it to run. Make sure that our strategy is running properly. Yeah, I'm learning Python because it seems more English writing the code. That's true. And quite relevant to quant field in order to handle ML models. Yeah, ML, Python is just the go-to language for ML, and it's probably always going to be. There are some cool tools coming out, but I think that it's going to remain the sort of dominant force for a long time. So we probably, if this was a real SMA strategy, we would, if we were going to implement this as like a live trading strategy, we would want to implement some logic for when the crossovers here are so small. But because we're never actually going to do that, that's no big deal. But one thing that we do want to have is these buy signals and sell signals seem to be incorrectly computed. So, oh, we're still using 10 and 20 here. So let's do target equals SMA2 close, target 2 equals SMA5 close, and then these should be target 1, target 2. SMA2 is creating noise. Yeah, that's kind of just how it goes when you have too short of an SMA period. So we have this. Where did I put the crossover code? Let's put this down here. And this should be target 1, target 2. So we'll just do this now. And as we get more data, we'll be able to swap to a much less noisy sort of, much less noisy interval. I just want to make sure that the signals are correct. Yes, okay, so they're correct now. And let's start looking out here. So our buy signal would be here because black went from below to above, and our sell signal where black goes from above to below hits there. Okay, so this is working. Now, let's put in some, let's do the logic for how we would do this. So, if we have a current buy signal, so in other words, how would we do this? Let's say, if, where are we? Crossover buy. So let's do this. If crossover buy dot iloc -1 equals true, then buy order elif crossover sell equals true, sell order. And so here we need to spool up the web app, or not the web app, sorry, the Kraken executions. And when we add order, do you have any take profit stop loss in your mind with this strategy? I mean, yeah, but I would never use this strategy. This is just for sort of setting up, making sure we can get the code working. Like I always do, I don't really do like a stop loss or a take profit, but what I do in the models is, I mean, when I'm like discretionary trading, I do. But for models, I much prefer to have just like good risk analysis going on. but it's sort of built implicitly into the fact that I'll show you here. When we do initial machine learning, this is the, oh yeah, so these models, this was with the very rough data. I think it was data labeling? Yeah. So I sort of implicitly have it built into the model. So what I predict is the fixed time horizon returns. So instead of implicitly putting like a stop loss or a take profit, I have the model trying to predict whether it's going to hit some threshold from the start price on the above, below, or if it's going to stay within the region for the whole time. And so that's sort of like implicitly a stop loss built into the model. And then you could have some real stop loss on top of it, take profit on top of it. But if you have a decent enough model, you probably won't go crazy outside of these ranges. But you could always set one outside of both of the ranges if you wanted, or even inside, technically. The problem with stop losses is like, yes, you do mitigate your losses, but when you think about the fact that trading is more of a long time frame thing, like you shouldn't be looking for, to hit like 10% returns in a day or something like that. Even on average, you shouldn't be looking for 1% a day. But you should be looking for something very modest, like a fraction of a percentage on average over the course of years. This is how you truly build wealth, right? Looking for huge returns on like an intraday time frame is effectively more of a gambling exercise. And so when I think of stop losses, I typically think of it like I'm sort of scared to lose money, but the model itself should have the risk analysis built in that you aren't going to have a big sort of swing there over long periods of time if your model is sound. Kind of focus much more on maximum drawdown. Yeah, but like the thing is this, your model, like this sort of standard logic in day trading is, here's my portfolio, my P&L. And people are typically hunting these kind of like big spikes, right? They want to hit like 20% on some option swing or something like that. But the problem is this is how it always looks in people's mind. And this is always how it looks in reality. Like you might hit a big thing, and then it's like, okay, you're basically screwed. Yeah, but even if you really shouldn't be trading like with margin. It's not really the right approach because the same logic applies. You can get a large swing in the returns, but the swing applies either way. And so anyone who's telling you they're making 1% a day is a liar. Just very clearly. It's just obvious because say you trade futures and you're hitting, 1% per day. Anyone who claims they're doing that consistently, even over a year, let's say they hit 1% a day, what's that? Probably like 30, 35 or 30, something like 35 to 40. So let's do it. 1.01 to the 365th power is 38x. So anyone who tells you they're making 1% per day, totally not true. That's 37xing your money per year. And the best hedge funds in the world hit, like literally the best fund ever is the Medallion Fund, which hit, I think, on average, like 67%. So if you do this built out for their thing, let's see. So this would be, what would it be? 1.67. So 1 plus n, where this is their daily rate of return. And to be fair, they trade on 252 days. Well, let's just say 365, just to get it annualized, as if they trade every day. What are we looking for? Equals 1.67. 1.67. So we take the this thing to the 1 over 67, and then we'll go for 1.67 this would be raised to the 1 over 365 minus 1, correct? Is that right? Did I do the algebra here? We raise both sides to 1 over 365. Yeah, that's correct. So let's plug this in. Let's go for like Wolfram alpha. I think it'll be a better thing here. 1.67 to the, what did I say? 1 over 365 minus 1. So literally, the top hedge funds in the entire world are hitting 0.1 or they're hitting 0.15% per day. Now, in reality, they trade 252 days a year, so it's something a little bit higher. 0.2% per day, right? So this is on average, n equals 0.2% daily returns. So anytime you see these like alleged swing traders claiming to make 1% a day, 3% a day on average. Now, of course, anyone can hit, you can hit 20% in a day. But what you're concerned with if you're trying to build wealth is hitting a consistent and ideally decorrelated from the market return per day. So the same people that are hitting 50% a day are guaranteed hitting minus 50% some days, right? Because this is a totally ridiculous risk strategy. And so this is why if you ever ask these people who claim to make, oh, I made 20% per day, it's like, okay, well, show me your P&L over a year. Show me it over 5 years. Show me it over even 1 year. They'll show you this where they go up 50%, but they will never show you this or even like this. They'll post their wins, but they won't post their losses, is effectively what I'm saying. And that's kind of the fundamental thing. Or the most important thing, in my opinion, is, I guess, tempering expectations when you come into trading. Many people come into trading thinking that they're going to make 2% a day, 3% a day. They think they're going to start with $1,000 and end up with $50,000. But when you put it into perspective like this is the return of the highest performing hedge fund in the history of all of the stock market. And they, on average, hit 0.2% per day. So it really does put into perspective what you can expect for reasonable returns and what you should feel good about, because you should feel good. If you hit 3% in a month, that's excellent. 3% in a month, even without compounding, is 36% a year. And that's amazing for an individual. Now, it may be higher in some years, lower in some years, depending on the market, because we can't perfectly decorrelate our returns from the market, especially as individuals. That's a really hard thing to do, because to decorrelate from the market, you need to have sufficient capital to invest in like a sort of diverse array of financial instruments, which maybe have a low overlap with common indices like VOO, VTT, S&P 500, any of these kind of more common investment strategies for, retirement and things like this. But you need a lot of money to be able to diversify in a way where you're also mitigating risk. Okay, so this is actually starting to look quite decent. So from black to here, so we have a buy, instant sell. So let's implement the logic here. Yeah, let's implement the logic. Oh, how did I thought I had the code. Oh, I put it up here. Let's grab this. Now, one thing I do need to add is the ability to just add an order for validation. And let me not run this right now. So we're also dealing with Bitcoin. BTC, BTC. Can I interrupt this? Let me cancel this so I don't accidentally buy a bunch of crap. Let's see. Have I accidentally bought anything? Do I have any buy orders? Oh, shit. Well, that's maybe not ideal. It actually makes sense in probability view and risk reward exposure. It does. Yeah, exactly. Because the sort of fundamental thing that goes into, so if you look up, I think everyone's maybe heard of stochastic. If you've looked into these things, you've heard of at least stochastic calculus. Calculus. Let's get the thing pulled up here. Now, the fundamental, where's a, can we get a better, oh yeah, let's go here. Do they have the derivation anywhere? This is the term. So the fundamental assumption of finance really is that the price of a stock follows in some sense, Brownian motion. Brownian motion is a process that originated in physics, but the key characteristic of it is that the variance of the thing you're tracking over time goes like the time step squared. So the variance scales like delta t squared. And the important thing here is that when you apply that to the typical definition of calculus for the derivative, you can no longer get this clean expression for the derivative of df dy equals, f prime of x evaluated at x, or let's say of t, I should say, f prime of t, and this should really be like a t. I have this written up actually pretty cleanly in one of these. I have the math here written up. Yeah, so here I kind of can read through this. Zoom out a bit so people can see. Or can we do, I don't like this. Can I get something like this? Yeah. All right. So the key assumption of typical calculus is that you can write the derivative as, if f prime is your derivative, it's like df dt, right? But in the assumptions associated with finance, the stochastic calculus comes from the fact that your variance of this function f with respect to t is proportional to dt squared. So in other words, this dt squared term is not small enough that you can say it's something we can ignore. And so when you plug this in, then if you were to solve for the derivative here, all of your calculus, things like integrals, derivatives, they become much more complex, and they become something which you have to solve using stochastic methods. And this is exactly why building the probability in these things on risk it's so important. If you don't have this built into your models, really, and you kind of assume that these prices are things you can just predict on historical data, then you're missing the point, which is that really it is an inherently stochastic process, and your models should build in some, stochasticity. I don't even know if that's a word, but they should build in some kind of some math, some methodologies to reflect the fact that these things aren't directly predictable from historical data. And that's sort of the fundamental assumption of technical analysis, is that you can predict future price based on past price, which is not true. And it's obviously not true because if it was, then the people with the biggest computers would just be wiping the floor with everyone. But these things adjust, and they adjust for what other people do. They adjust for market conditions. They adjust for real life events that no one can predict. So, I mean, insofar as you accept that the news can affect the price of stocks, if you can't predict the news, which obviously you can't, it's not possible. Yeah, price is, it's close to random. And finding small things that may lead you to predict that it's far from equilibrium, or, these things, it's these small things that result in small changes in price that maybe you can predict and get some edge on. Because it's mostly random, yeah. Or it's so complicated that it seems random. at the very least. Predicting the stock market is, you know, the same problem effectively as predicting what billions and billions of people do. Yeah, random walk theory is so random walk is a Brownian process. So when you have a random walk, you have some fixed step size. You can go up one or down one each time. So you might go like this, something like this. And because this is a Brownian process, you can estimate d of t, which is your distance from the origin, if this is 0. D of t is proportional to the number of steps, which we'll just call dt, and dt squared. So if you try to estimate this function and its derivative as a function of time as simply df dt, you're missing the fact that really the derivative and change of this function with respect to time, you're missing the fact that it also depends really more so on this variance with dt squared. So you need something like d squared f dt. And I think I did the math wrong here, but there should be some dt squared term here. I think this term is missing something, but regardless, the point is that your derivative is much more complicated than this when you want to take the time derivative of a function like a random walk, which goes as a stochastic process. What term should be there? There should be some term on that first. Oh, there should be one of these mu terms, and this mu term has to do with the average. So that's what, there should be some term here, but we're just kind of sketching it out while discussing these things. But it makes sense when you think about it. And, the other reason, sort of related to this, the reason I don't like backtesting is imagine if this was like, heads, tails, and we're dealing with a coin. You could very easily imagine that you get some number of heads and tails, right? You could very easily imagine, and this is why I don't like backtesting. You could imagine some series of coin flips, right? Over time. And if you had enough of these and you had enough compute power and enough parameters in your model, you can fit a function to this very easily. But it sort of circumvents the fact that this is still a random process. And so you can overfit any sort of model you want, any big enough model you want to a historical data. It's the same exact thing with price of a stock. You can fit a model to any complex price of a stock, but even if it fits historical data, if the process inherently has some randomness to it or some unexplained variables by your model, it's not going to perform well in the future. This is why backtesting is such a dangerous thing if you take it as like gospel truth. It's not really possible to extend that into the future because fundamentally with the head and tails, it is truly random, more or less, right? It's closer to random than stock prices, but it illustrates the fact that just fitting a curve doesn't necessarily mean you're doing too well. Okay, and so let's try to wrap this up. One thing I wanted to check was if the when we add in order, is there some flag we can do to just do a test? Can we do like test? Validate. Okay, here we go, validate. If set to true, the order will be validated only. Okay, I want this. Where is this? Is this params? So it's right within the params object. Is that right? Method. Oh, so it's within method. Let me see. Method per. Okay, so it's in params here. Let's modify the code a little bit. Actions. On message. No. How about add order? So let's pass in validate. Do we use that though? If order type is limit, let's pass in validate. Validate, validate. I still need to implement some of these different types of orders, but we'll kind of continue to build this out as we go. How do you fit mathematical equations or theories to trading logic? Any book or study source you can recommend? It sort of depends on the type of thing you trade. Some very general things you could look into are like ARIMA. That's a good introductory sort of thing. So you can look up ARIMA models. These are basically integrated moving averages. And so they assume some things about the price, like the price has to be stationary. I'm sure it'll say that here. So it represents the differencing of our observations to allow time series to become stationary. And that's sort of a fundamental assumption of these things. So you have to understand the assumptions of everything. But if you're interested in pricing options, you can look at the Black-Scholes model. You can look at the binomial pricing model and see how relatively few parameters can get you decent pricing strategies. Black-Scholes, if you're interested in the math we were just talking about, is a good example, because Black-Scholes is basically, it's a particular solution to this Ito integral that we were just looking at, with some initial conditions that you could set from known things like the price of the stock, the strike price of the option, the time to expiration. When you have those as boundary conditions for your integral, you can solve it explicitly, and you can get what the quote unquote fair price of the option is at a given time. And that allows you to do all sorts of things like extract the implied volatility from the option, or of the underlying asset, I should say. So look into Black-Scholes. A good book would be Option Pricing and Volatility. It's a bit math heavy though, fair warning. If you're, depending on your math level, it's a bit math heavy. It's a good one. Advances in Financial Machine Learning is pretty good, but if you want the more mathy side, I would recommend a thing like this. I'm sure there are pricing futures textbook. I think there's one, I don't really remember. Well, of course, this is maybe fundamentals of futures and options markets, a decent one. But pick a textbook, really, any textbook. Not super important. The main thing is that you kind of make sure you get through the whole book, or at least get through the parts that you're trying to understand. So testing bot, we'll bring this over here. Actions. And what are we looking at here? Do I follow Martin Armstrong? I don't know him. So I don't really know too many people in this space. I'm guessing he's a finance person. Looks like maybe not the guy to follow. Cheating investors out of 700 million. No, I have not heard of him though. But I guess maybe he's out now. Maybe he's a reformed man. He's not a felon. No, different guy. Where are we? Yeah, so I want to add these validate methods. So validate. No, that's him. Wow, it seems like maybe he's not the best guy. I don't know if I want to follow him. I guess there are two sides to every story, to be fair. I don't know him, so maybe he's a stand-up guy now. Or maybe he was maybe he was done wrong. There are some of these people that, they claim that, they do something wrong, and then all of a sudden the SEC is all over them. So you never know. Could happen. Yeah. I know Shkreli says that, right? Shkreli says he upset the wrong guy, and someone ended up making the call, and then 2 weeks later he's in court. So it happens, I'm sure. Okay, let me zoom out a little bit here. Data labeling. Oh, I'm on the wrong thing. Let me X this out. I keep getting confused. I wish you could have two different color themes for the windows. I'm sure there's a way to do it. I need to find out how to do that so that when I alt tab, it's so confusing. Okay, so we have a limit order. Probably, so in the testing block, let's do a limit order when we place. And this is actually good because I'll be able to just put the price to some nonsense low value. So let's not worry about the sell orders for now. Let's worry about the buy orders. Side buy, order type, market. Nope. Order type, limit. Oh, yeah. Yep. Definitely no. Definitely no Simons. He's like his churn Simons thing is a big thing in the field of science that I work in. So very relevant for all these kind of cool types of materials where, you know, maybe they're a conductor, like you have a conductor, or they're an insulator, right? Like maybe a solar cell is a semiconductor. But there's something with that Chern-Simons theory that he has where some of these things which don't conduct electricity, certain ones of them, and they're very exotic materials, certain ones of them, at the boundary of them, you'll have these states that do conduct electricity. And that's a direct consequence of the something to do with his Chern-Simons theory. And so it's kind of cool. Such a well-known guy in finance has such broad-reaching implications in these other fields. So we'll put the buy price as like 50,000. This will never execute. Bitcoin USD, and he was also kind of like one of the first guys to really be doing machine learning, deep machine learning, and fully automated trading. And he's the one who founded that medallion fund I was talking about earlier. I think he just died though recently this year. So limit price. Okay, so let's check this and let's pass validate equals true. Print running here. So let's run this now. I guess it's kind of going to be something where, oh, we have an error. Truth value of a series is ambiguous. Where? Why? Let me see this. Let's go to a new cell here. Why is this scrolling so slow? What was it called? Crossover by. Crossover by .iloc -1. Why is it return? Can we do value? Oh, shoot. Should be. Wait. So what's the problem here? I'm trying to think. So crossover by. Oh, crossover by is a data frame of all of our rows where we have a crossover corresponding to a by. So what's the best way to deal with this? So what we should really probably be doing is if df, let's do df.head. Are they all the same columns? Let's check if the columns are the same. df.columns equals crossover by.columns. Okay. So we can do if df.iloc -1 equals, then we should be, okay, you can't do that. If, numpy dot, can we do all? How do we do all? Okay, this works. Else print df, or print df dot iloc -1. And David Shaw is known for, yeah, yeah. He's one of those names that pops up all the time. I don't know too much about him. He has a good textbook, doesn't he? He definitely has some good textbook. The E. Shaw textbook. Oh yeah, he does. It's oh no, maybe he doesn't. Nope, definitely not that one. David Shaw finance textbook. Does he not? Thought he did, maybe not. But yeah, he's one of those legends in the space as well. Okay, so this was a false for crossover. So this is what we need to be checking. We need to check if, because our crossover buys are simply the, what are they? They're the data frame rows where we have a positive crossover. That's what we need to be checking for our buy conditions. So it should be this instead. Okay, can we, there we go. No, he's not social. Yeah. So we would have a crossover there. Let's make sure this thing is still live updating. Let's also make sure it's still tracking Bitcoin decently well. So how far back are we? Where's our first time? 2040. Let's zoom this out a bit to 2040, something like this. And then let's zoom this to match, see how our bars look. Yep. So we for sure ironed out the bug with the candlesticks. That's good. And yeah, that's pretty much it. Now this is working. Can we please hit a crossover? How did we not hit a crossover here? Maybe it should be the next 1 minute. Should be, right? Someone has to cross over here. What are we looking for? Black and green crossovers? No, of course not. Okay, well, you know what? Let's do this. Let's simply say, if true, I'm confident that this logic will work, so let's just go for, true. Let's throw in a little buy order. And let's see what we get for errors, because I'm sure it will not work. Yeah, order type. Add order got unexpected thing called order type. Let's check about that. Order type. Oh no, it should be an action, sorry. Order type. How did it get an unexpected? Oh, there's no underscore. Order type. And now let's run this. Volume. What's it called? Size. Order quantity. My alt tab is all messed up. Don't know why. Order type, side, by, volume. Order, QTY. WebSocket is not connected. Cannot submit order. Okay. Now, let's see. WebSocket is not connected. Okay, so we need to connect. So we're in connected.set. So where do we connect? My alt tab is all messed up. Oh, we need to do exec.launch, I believe. Is that the correct? what do we call it? Where do we exec.start WebSocket? I cannot alt tab into this for some reason. Start WebSocket. Okay, so it ran. Oh, I want the full output. And let's see what is happening. Let's also print the message, I guess. Let's also cancel this in case it is destroying my account right now. Why can I not alt tab into this thing? It's so annoying. Let's interrupt this. Let's double check. So I put them at 50K, meaning we have to way zoom out. Yeah, so nice. It is working. But why is it's supposed to be only validating and not actually using these? So that's kind of annoying. But we have it working. So it takes the buy signals and now it can implement the orders for some arbitrary strategy. And I am very hungry. We've been live for about 3 hours, so I'm probably going to hop off here in a sec. Appreciate you guys joining. Let me send the Discord link again. I don't know if you're all in there, but if you want to join, feel free to join the Discord. Send that in there. And yeah, I think I'm going to hop off, go grab something to eat. Maybe I'll work on this a little bit later. It has some rough spots around the edges, but we have it working. So we can take positive trade signals as well as, negative trade signals and automate the trades. So this basically is a very rudimentary still, but, working algo trading framework. So we have this. Will I share the code? Yes. Next. So I don't want to share it now while it's so broken because I don't want people to use it and it's still very buggy. Like we have pretty much everything working, but once it's not so buggy, which I'm targeting next Friday, will be like the official release date of the code. For sure, I'll be sharing it. And yeah, so that'll be cool. Hopefully next Friday. I'll still be streaming every day working on it. And if it's, I'm not going to rush it. So if it is in a spot where we're still having all these kind of buggy order things, I won't put it out yet. But as soon as it's working and I feel like it's relatively safe for people to try on their own, yeah, I'll do it because I have a account with a pretty small balance now. So worst case scenario, it's going to be not ideal. What time stream? In the week. So on the weekends, it's been a little bit hectic, but on the weekdays, it's always. Let me think. In my time, it's around 6 to 7. So 8:30 Eastern time for US is roughly when I start the streams on the weekday. And I'll always at in the Discord too, like 20 minutes before I end up going live. Alrighty. Yeah, I really appreciate you guys joining, talking. Makes it much more fun when we have stuff to talk about. Joining on the next live stream, awesome. Sounds good. All right, so I hope you guys have a good rest of your weekend. I'm going to close it out here and say, yeah, hope you all have a good rest of your day.